Okay, here's a real quick video on how to use this TI-30XS Multiview calculator to do two variable statistics. So, from it being off, you want to just turn it on, and I want to enter data. So press the data key. There are three lists. I'm going to put my X values in the first list, and I'll put my Y values in the second list. I'll just make up some numbers. And to do something simple, why don't I pick X's like 10, maybe 20, 30, 40, and 50. And for fun, I'll just make a thing work perfectly. Let's try values like 50, 60, all in a straight line, 70, 80, and 90. So I have the same number of Y values as X values. When I'm done, I always go quit. Second quit is a good way to get out. If I want results, I go second data, where it's labeled stat in green. Now I'm doing two variable statistics, so I have to highlight the second option, hit enter, and now I have to tell it where I put things. I put my X data in list 1, so I highlight that, and I put my Y data in list 2, so I highlight that. Then I'm ready to calculate, and it tells me everything I need to know. N is 5, that means I entered 5 pairs of points. The mean X value is 30. The standard deviation for the X is 15.8, and the other standard deviation, where you divide by N instead of N minus 1, gives me the average Y, the standard deviations for the Y, some of the X's, some of the squared X's, some of the Y's, some of the squared Y's, some of the XY's, everything. But the three things you're interested in are the A, the B, and the R. On this calculator, the A is the slope of the line of best fit, B is the Y-intercept, and R is the correlation coefficient. So since I made points that lined up perfectly, my slope is exactly 1, my y-intercept is 40, and my correlation is perfect at 1. It gives me some other things too. It'll give me equations that can predict an x if I input a y, and predict a y if I input an x. Like if I want to ask what would y be if I plugged in x equals 25, it'll tell me that it would be 65 for the line of best fit. Now let me doctor things a little bit. I'm going to quit out of this, go back to modifying the data. Let me make it imperfect. Instead of 50, I'll make it be 51. And maybe I'll change the 70 to 72, and why don't I change the 80 to something like 78. So now the line won't be perfect, but it'll be close to the same. So I'll quit the data, go back to the statistics thing. I'm doing two variable statistics. I'm still using the first list for X's and the second list for Y's. I calculate away. I've still got 5 data points. All this stuff is going to be similar. Now, notice that the A, the slope changed a little bit. Now it's 0.96. The intercept changed a little bit, 41.4. And now my correlation isn't perfect. It's close. It's 0.996. It's still really good, but not quite perfect. So, that's the way to play with these things. It gives me a few more pieces of information, but all I'm really interested in are those three things, the A, B, and R. Okay, good luck.